The dark energy mystery. Is the universe pulling apart? The force that shouldn't exist. Something impossible is happening across the universe. Galaxies are fleeing from each other faster than ever before. Stars that once gathered in clusters are drifting apart into silence. The farther we look into the cosmos, the more it seems to be stretching, not just expanding but accelerating, as if an unseen hand is pushing everything away. For centuries, physicists believed that gravity was the great sculptor of the universe. It pulled matter together, built galaxies, and gave shape to the night sky. It was the law that promised a future of balance. But in 1998, everything changed. Two teams of astronomers, studying distant supernovae as cosmic mileposts, found something that defied every law we knew. The universe was not slowing down as gravity should have demanded. It was speeding up. Space itself was expanding at an accelerating rate. What could drive such an effect? There was only one explanation: some unknown energy embedded in the vacuum of space that acts opposite to gravity, a pressure of nothingness pushing against everything. Scientists named it dark energy because that was all they could call it. Dark for its invisibility, energy for its influence. But the name solved nothing. It was a label for ignorance, a title for the unknown. Today, more than 2 decades after that discovery, we still know almost nothing about it. Dark energy makes up nearly 70% of the entire cosmos, and yet we have no idea what it is made of, where it comes from, or why it began to dominate the universe at precisely this point in cosmic history. Every galaxy, every atom, every second of time moves within its grasp. It is the most powerful force ever observed, and the least understood. What makes it so haunting is not only its mystery, but its paradox. Dark energy is not something in space. It is something about space. The very fabric of reality is producing energy from nothing. As the universe expands, more space appears, and with it, more energy. It's as if the cosmos is creating something from emptiness, a process that defies every conservation law we've ever written. The universe, it seems, has learned to accelerate itself. If this continues indefinitely, it leads to a terrifying scenario known as the Big Rip, a future where expansion becomes so powerful that galaxies, stars, and even atoms are torn apart. Space doesn't just grow, it shatters. The very framework of reality unravels, leaving nothing but cold isolation between remnants of what once was. But some scientists propose a different fate, that dark energy may weaken, that its pressure may fade, allowing the universe to slow and eventually collapse back upon itself in a big crunch. Others believe it will persist forever, freezing the cosmos in eternal stillness. Whichever path is true, one question remains: why now? Out of all the epochs in cosmic history, why do we live at the precise moment when dark energy has begun to dominate? For the first 9 billion years, gravity ruled. Then, suddenly, this mysterious force took control. The odds of observing this transitional era by chance are infinitesimally small. Some cosmologists call it the coincidence problem. Others whisper about deeper possibilities, that the universe itself may be fine-tuned, or that consciousness and cosmic balance are somehow intertwined. What if this acceleration is not random? What if dark energy is not the destroyer of the universe, but a mechanism, a signal written into the laws of physics, pushing the cosmos toward transformation? Could it be that the universe is not expanding away from itself, but into something greater, an evolution of space, energy, and perhaps awareness itself? When we gaze at the night sky, we see beauty, order, and distance. But beneath that stillness, everything is moving faster than we can comprehend. We are part of a grand unfolding, creatures made of atoms held together by forces we barely understand, living in a reality that is quietly changing its own rules. This is the story of the invisible engine driving all existence, the force that shouldn't exist, yet defines everything that does, the energy that builds nothing, but moves everything. This is the mystery of dark energy, and if we're brave enough to follow its trail, it may reveal not just how the universe ends, but why it began. Before we continue, pause for a moment. You're watching the universe reveal one of its deepest secrets, something that reshapes everything we think we know about time, gravity, and existence itself. If this journey already made you question what lies beyond the visible, subscribe now, not for the algorithm, but for awareness. Because here, we don't just watch the cosmos, we listen to it. And what comes next may change the way you see reality itself. The discovery that changed everything. At the end of the 20th century, astronomers were confident they understood the universe's story. It began with the Big Bang, expanded rapidly, then slowed down under the pull of gravity. Everything, from stars to galaxies to the cosmic web, was expected to move gradually toward equilibrium. That was the narrative written into textbooks, the law of cosmic reason. Then, in 1998, the universe broke its own rule. Two teams of scientists, working independently on opposite sides of the planet, were observing a class of distant exploding stars known as Type Ia supernovae. These supernovae burn with predictable brightness, making them perfect cosmic rulers. By measuring their apparent dimness, astronomers can estimate how far away they are and how fast the universe is expanding. What they expected to find was simple. The farther away the galaxy, the slower its outward motion should appear, because gravity, pulling on all matter, should gradually be decelerating cosmic expansion. But the light told a different story. Those ancient supernovae, flaring across billions of light years, were too dim. They were farther away than the equations predicted. That meant the universe's expansion was not slowing down. It was speeding up. Galaxies weren't just moving apart. They were fleeing from one another with ever-increasing velocity. The cosmos was accelerating into emptiness. This discovery wasn't just unexpected, it was impossible. No known force in physics could cause space itself to accelerate outward. Gravity could pull, but nothing could push. The universe, by all logic, should have been slowing down. Yet the data, painstakingly verified by both teams, refused to lie. In that moment, cosmology cracked open. Everything we thought we knew about the destiny of the universe was suddenly wrong. The cosmos was no longer a predictable, mechanical system winding down like a clock. It was a living, expanding mystery, driven by an invisible force that no one could explain. To make sense of this discovery, scientists resurrected an idea first proposed and later dismissed by Albert Einstein: the cosmological constant, a term representing an inherent energy within space itself. Einstein had added it to his equations in 1917 to keep the universe static. When the expansion of the universe was later confirmed, he called it his greatest blunder. But now, decades after his death, that same concept returned, not as a mistake, but as the only explanation that fit. Einstein's blunder became our greatest clue. Space, it seemed, was not empty. The vacuum itself possessed energy strong enough to counteract gravity and accelerate the expansion of the cosmos. The implication was staggering. The universe wasn't coasting outward through an empty void. The void itself was alive with energy, swelling the very fabric of space-time. Scientists named it dark energy, though that name concealed more than it revealed. It wasn't dark in the sense of shadow or matter. It was dark because it was invisible, undetectable except through its effects. And it wasn't energy as we understand it. It didn't radiate, vibrate, or decay. It was everywhere and nowhere, constant and immeasurable, quietly rewriting the fate of everything. The scale of this realization was almost unbearable. Suddenly, all the stars, galaxies, and nebulae, the entire luminous universe, accounted for less than 5% of existence. About a quarter was dark matter, unseen but measurable through its gravitational pull. And the remaining 70% was this: dark energy, an unseen force driving everything apart. For the first time in human history, we understood that what we can see is only a small fraction of what is real. The cosmos we admire through telescopes is merely the surface of a far deeper, stranger reality. This revelation sparked one of the greatest intellectual revolutions since Copernicus. Just as Earth was once displaced from the center of creation, now matter itself was displaced from the center of existence. We are not built from the dominant stuff of the universe. We are the residue, the visible trace of something vast and invisible. but the discovery raised more questions than it answered. What is this energy? Why did it begin to dominate the universe only a few billion years ago? And why does its strength seem perfectly balanced? Not enough to rip galaxies apart instantly, but enough to overcome gravity over time. Some physicists saw it as a coincidence so unlikely that it borders on design. Others began to suspect that our universe might not be alone, that in a multiverse of infinite realities, we simply live in the one where the numbers allow for life to exist. Whatever the explanation, one fact became clear. The universe is far more complex and far more fragile than we ever imagined. The discovery of dark energy wasn't just a moment in science. It was a moment of humility. It reminded us that our instruments may measure galaxies, but they cannot yet measure truth. The acceleration continues. Every second, space stretches, galaxies drift farther, and the fabric of reality grows thinner. Somewhere beyond our reach, the first galaxies that formed after the Big Bang are now vanishing over the cosmic horizon, pulled away faster than light itself. We will never see them again, and that realization carries a quiet weight. We are living in a rare, transitional era, a universe still visible, still luminous, still connected. But in the distant future, even the nearest galaxies will fade from view. The cosmos will become dark again, as it was before stars were born. To understand how this story began, we must look deeper, beyond galaxies and mathematics, into the invisible framework that holds the universe together and now seems determined to pull it apart: the cosmic web and the balance of forces. When we look at the night sky, we see points of light scattered across a dark canvas. But that simplicity is an illusion. If we could step back far enough, far beyond galaxies, beyond clusters, beyond superclusters, we would see that the universe is not random. It is woven into a colossal, intricate web. The cosmic web is the largest structure in existence, an immense network of filaments made of galaxies, gas, and dark matter stretched across hundreds of millions of light years. Between those filaments lie vast, empty voids, cosmic deserts where light rarely passes. In this web, gravity acts as the thread, pulling matter together into strands and knots, while dark energy works as the great unraveler, pushing everything apart. For billions of years, gravity dominated this struggle. It gathered hydrogen into stars, stars into galaxies, and galaxies into clusters. The universe grew richer, denser, and more complex. Every element, every molecule, every cell in your body exists because gravity once won that ancient war. It gathered chaos into form, but that age is ending. Now dark energy is winning. To understand this transition, imagine a tug-of-war played out across the cosmos. On one side, gravity, the attractive force that pulls matter inward, creating structure and cohesion. On the other side, dark energy, a repulsive pressure that stretches the very fabric of space. For billions of years, gravity was stronger, shaping the web of galaxies that gave birth to stars, planets, and life itself. But around 5 billion years ago, something shifted. The scales tipped. Dark energy began to dominate, and the universe's expansion entered a new phase, one defined not by creation, but by separation. The balance between these two forces defines everything that exists. Without gravity, there would be no matter, no stars, no us. Without dark energy, the universe might have collapsed back upon itself long ago. Their rivalry is not chaos, it's equilibrium, a cosmic equation written into the foundation of reality. And for reasons we do not yet understand, that equilibrium seems precisely tuned. This fine-tuning is one of the greatest puzzles in cosmology. If dark energy were even slightly stronger, matter could never have clumped together after the Big Bang. Stars and galaxies would never have formed. If it were weaker, gravity would have triumphed, and the universe might have collapsed before life ever had a chance to emerge. Yet here we are, existing in the narrowest possible window between two extremes. It is as if the universe were balanced on a knife's edge, between expansion and collapse, between order and oblivion. Some call this the coincidence problem. Why does dark energy begin to dominate now, precisely when intelligent observers exist to notice it? Why not billions of years earlier or later? There is no known reason, only the haunting possibility that the laws of the universe may not be arbitrary at all. Some physicists suspect that this delicate balance points toward a deeper structure beneath reality, something beyond our equations. Perhaps dark energy and gravity are not enemies, but complementary aspects of the same cosmic mechanism. Gravity shapes the visible universe. Dark energy shapes the invisible one. Together, they may form a kind of universal breathing, an oscillation of creation and dissolution that repeats across eons. If this is true, then the universe is not merely expanding, it's responding. Space and time themselves may be alive in a way we cannot yet define, a self-regulating system that grows, evolves, and remembers. The cosmic web would then be its nervous system, an endless network through which energy, matter, and information flow like signals in a brain. Each galaxy would be a node, each star a neuron, all connected through invisible filaments of gravity and vacuum. In this view, the accelerating expansion is not destruction, it is transformation. The web is not being torn apart, it's changing shape. Perhaps the universe is moving toward a new phase of existence, one where the rules of matter give way to something else. Yet for now, this balance remains fragile. The filaments of the cosmic web still stretch, but not infinitely. Gravity still holds clusters together in small sanctuaries of stability, while dark energy pushes the empty voids wider. The result is a universe in transition, half bound, half free. A universe alive with tension, caught between memory and momentum. And that balance determines not only the future of galaxies, but the fate of meaning itself. Because in a cosmos defined by opposing forces, everything we know, creation, life, awareness, arises in the brief moment between order and disintegration. The question we must now ask is not how the universe expands, but why it expands at all. What is this invisible force that pushes against gravity's pull? What is dark energy really made of? To explore that mystery, we must look closer, not into the visible filaments of the cosmic web, but into the vacuum that surrounds them. For it is not the stars or the galaxies that drive the universe's expansion, but the emptiness between them. And in that emptiness, something extraordinary is happening. The physics of nothing. At first glance, emptiness feels simple. A vacuum should be the absence of everything, the silent gap between stars, the void that stretches across light years of darkness. But in physics, nothing is never truly nothing. The vacuum is alive. It seethes, vibrates, and fluctuates with invisible forces. It may even hold the key to the greatest mystery in the cosmos, the origin of dark energy. In quantum physics, the vacuum is not an empty stage. It's the stage itself. Even when all matter and radiation are stripped away, fields remain. They oscillate with ghostly energy, birthing and annihilating particles faster than thought. This restless undercurrent is called vacuum energy. It exists everywhere, at every point in space, an invisible storm beneath the illusion of stillness. If dark energy is the pressure that drives the universe apart, then vacuum energy is the most obvious suspect. The equations even seem to agree. According to quantum field theory, every point of space should contain an unimaginably tiny amount of energy, so tiny we never notice it. But when physicists tried to calculate it precisely, the result was catastrophic. The predicted value of vacuum energy turned out to be 1/120 times stronger than what we observe in reality. Not 10 times, not 1,000, but a number so vast that it defies comprehension. This is often called the worst prediction in the history of physics. If that value were correct, the universe would have torn itself apart the instant it formed. Instead, it didn't. Something canceled that energy almost perfectly, leaving behind only a faint residue. That residue is what we now measure as dark energy. But the precision of that cancellation is too exact to be coincidence. It's as if the universe were engineered to balance on the edge of nothingness, suppressing nearly all its internal pressure, yet leaving just enough to keep expanding. This impossibly delicate fine-tuning has haunted physicists for decades. What force could adjust the energy of the vacuum with such precision? What cosmic mechanism could silence infinity, leaving only a whisper? Some propose that the vacuum energy might not be constant at all, that it changes over time. They call this dynamic version quintessence, an evolving field that waxes and wanes with cosmic expansion. In this model, dark energy is not a fixed background but a living field, slowly shifting as the universe grows. If true, this means the cosmos is not just expanding, it's reacting. Space itself could be adapting to its own evolution, maintaining balance like a living organism regulating its heartbeat. Others push the idea further. They suggest that what we perceive as dark energy might not be energy at all, but geometry, a property of the universe's shape. In Einstein's equations, the curvature of space-time and the energy it contains are two sides of the same coin. Perhaps dark energy is the curvature expressing itself, the universe flexing its own fabric in response to its contents. Expansion, then, would not be caused by something. It would be something, an emergent behavior of the vacuum itself. But even that explanation may not go far enough. Some theorists imagine that our universe is just one bubble in a vast multiverse, where each universe has its own laws, constants, and vacuum energy. In most of them, the vacuum is too strong or too weak for stars to exist. But in this one, ours, it happens to be just right. We exist because the vacuum energy sits in that narrow, improbable range where atoms, gravity, and consciousness can coexist. The universe in that view is not special because it was designed for us. It's the only one among countless others where life could even arise to ask why. Still, for every theory, one truth remains. The vacuum defines reality. When we say the universe is made of 70% dark energy, what we really mean is that nothingness is what holds it together and pushes it apart. The void between galaxies is not dead space. It's the dominant substance of existence. The stars, planets, and people are small details floating on the surface of a deeper ocean, an ocean of invisible energy that defies logic and expectation. To grasp this paradox, imagine a universe that feeds on its own emptiness. Every time space expands, more vacuum appears, and with it, more energy. The act of growing creates more of the fuel that drives the growth. This is why expansion doesn't slow down, it accelerates. The universe is like a fire that burns not on matter, but on nothing itself. If this seems impossible, it's because it should be. Physics, as we know it, was not built to describe a cosmos that grows from nothing. Yet every observation tells us it's true. We are witnessing creation in real time, not creation of new matter, but of new space. The vacuum is not passive, it's productive, and dark energy is its signature. The universe, then, may not be a static container of things. It may be a process, an unfolding of geometry, energy, and awareness that transforms absence into expansion. In that sense, dark energy isn't the enemy of existence. It's its engine. But every engine runs toward an end. If the vacuum continues to produce energy, if the expansion never stops, then the universe we know will one day dissolve into its own creation, an endless sea of cold light and infinite distance. Before we face that possible future, we must understand something deeper, how the invisible vacuum interacts with the visible universe. Because to truly know what dark energy is, we must study what it does, to matter, to gravity, and to the structure of everything we see. Gravity's last stand. For all of cosmic history, gravity has been the quiet sculptor of everything we know. It gathered hydrogen into stars, fused stars into galaxies, and pulled galaxies into clusters. It shaped planets, black holes, and the arcs of light that cross the heavens. For billions of years, gravity was destiny. It was the language through which the universe built itself. But now, that language is being rewritten. Somewhere about 5 billion years ago, something subtle began to happen. The cosmic expansion that had been slowing since the Big Bang began to quicken again. Galaxies that should have been falling toward one another started drifting farther apart. Clusters began to loosen. Space itself was stretching faster than gravity could bind it. At first, this defied imagination. Gravity was supposed to be the ultimate power, the unbreakable force of attraction that shapes time and matter alike. Yet, as scientists measured the distances between galaxies with greater precision, they realized something devastating. Gravity was losing. the universe had entered a new era, an era of disconnection. To understand this cosmic turning point, imagine the universe as a vast network of galaxies connected by invisible threads of gravity. For billions of years, those threads held strong, keeping clusters intact, shaping the grand architecture of the cosmos. But dark energy acts like a constant outward pressure, stretching those threads ever tighter. Over time, that tension grows, and one by one, the connections begin to snap. In this slow-motion unraveling, the cosmic web doesn't collapse, it thins. Galaxies that were once neighbors drift beyond each other's gravitational reach. Each cluster becomes an island, isolated in an expanding sea. The night sky in the far future will no longer resemble the star-filled canvas we see today. It will become sparse, lonely, and dim. The great structures of the universe will drift beyond visibility, retreating over the cosmic horizon until they vanish altogether. This process is not violent, it's silent, graceful, almost mournful. Gravity does not explode or fail, it simply fades. As space expands, its ability to pull objects together weakens. Galaxies will remain bound internally, held together by their own mass, but everything beyond their edges will recede faster than light. The cosmic network that once defined creation will dissolve into solitude. This transition marks the end of the era of structure, the age when gravity's touch could still weave the universe into coherent forms. Ahead lies the era of isolation, when the force that gave birth to stars and planets becomes powerless against the growing void. The same gravity that forged existence will one day watch it drift away, unable to follow. Yet this defeat reveals something profound. Gravity, by its nature, pulls things together. Dark energy pushes them apart. For eons, these two forces have waged a perfect balance, a cosmic dance that allowed galaxies, life, and consciousness to exist. Gravity built the stage, dark energy is now taking it away. But neither is evil, and neither is good. They are complementary. Without gravity, there would be no form. Without dark energy, there would be no motion. Einstein's general relativity describes this relationship as a conversation between matter and space. Matter tells space how to curve, and space tells matter how to move. For most of cosmic history, that conversation was balanced. Now, however, dark energy is raising its voice, bending the geometry of the universe in ways that no star or black hole can resist. The universe itself has become an instrument playing two notes, attraction and expansion, locked in a harmony that defines reality. But that harmony is changing. If dark energy continues to accelerate, the universe will eventually reach a state where even galaxy clusters, once the largest gravitational entities, are torn apart. And if its strength increases exponentially, as some models predict, even the atoms within stars will be pulled asunder. This scenario is known as the Big Rip, a cosmic crescendo where the fabric of space-time tears itself apart. Before that moment arrives, there will be signs. The first will be silence. Not the silence of sound, but of light. Distant galaxies will fade as their light stretches beyond the visible spectrum. Then gravity itself will begin to lose grip on smaller and smaller scales. The Milky Way will remain intact for billions of years, but eventually it too will be severed from every other structure. In the final age, even gravity will be unable to hold the atoms of matter together. Some cosmologists, however, see another possibility, a faint hope within the equations. Perhaps dark energy is not constant. Perhaps it evolves. Recent studies of the cosmic microwave background and deep-field galaxies suggest that its strength may fluctuate ever so slightly over time. If that is true, there is a chance that gravity might yet reclaim balance. The cosmic expansion could slow, stabilize, or even reverse. That would mean the universe might one day contract, drawn back by gravity's enduring pull. Space would shrink, galaxies would converge, and time itself could loop toward a new beginning, a big crunch followed perhaps by another big bang. In that cyclical vision, gravity is never truly defeated. It only sleeps, waiting for its turn to rise again. Either way, what we are witnessing is the most profound tension in existence, the conflict between unity and separation, between form and freedom. Gravity binds, dark energy liberates. But liberation at the scale of the cosmos comes at a cost: the loss of connection, the quiet death of structure, the loneliness of eternity. To see where this struggle leads, we must travel deeper, beyond matter, beyond light, into the hidden geometry that shapes both forces. For behind the rivalry of gravity and dark energy lies a deeper question. What is the universe expanding into? The shape of the universe. Every story needs a setting. For ours, the stage is space itself, vast, curved, invisible, and expanding. Yet, even after a century of observation, we still do not know what the shape of the universe truly is. Is it flat, bending back on itself like the surface of a sphere, or curving outward like a saddle stretching into infinity? The question is not just mathematical. It defines the fate of everything. To understand why, we must first imagine the universe not as a static space, but as a fabric, a dynamic field woven from geometry and energy. This is the legacy of Einstein's general relativity. Space is not emptiness, but a structure capable of bending, stretching, and evolving. Every particle, every star, every galaxy presses into this fabric, curving it slightly, creating the phenomenon we perceive as gravity. But if mass curves space inward, something must curve it outward. That something is dark energy. The geometry of the universe depends on which of these forces dominates. If gravity were stronger, the cosmos would bend inward, eventually collapsing back into itself. If dark energy were stronger, it would push space outward endlessly, flattening and stretching it until no curvature remained. The balance between the two determines not only shape, but destiny. For decades, astronomers have searched for an answer. Using the cosmic microwave background, the faint afterglow of the Big Bang, they have mapped the universe's geometry with exquisite precision. The results are startling. Within experimental error, the universe appears flat. Not curved inward or outward, but balanced almost perfectly between the two. That flatness is not ordinary. It is impossible to explain without extraordinary fine-tuning. At the moment of the Big Bang, the total energy of the universe must have been equal to zero. Matter pulling inward, dark energy pushing outward, in perfect equilibrium. If those forces had differed by even 1 part in 1060, the universe would have either collapsed immediately or expanded so fast that galaxies could never form. The fact that it balanced so precisely has led many to suspect that the universe is not random at all, that something or some principle set the initial conditions with unimaginable precision. This is known as the flatness problem, and it remains one of the great unsolved riddles of cosmology. The most accepted explanation is called cosmic inflation, a brief moment just after the Big Bang, when space expanded faster than light itself, smoothing out any curvature and leaving behind a universe that appears perfectly flat. But even inflation raises deeper questions. What triggered it? What stopped it? And why did it happen in a way that allows for life, complexity, and consciousness billions of years later? The simplest models of inflation predict a multiverse, an infinite sea of expanding regions, each forming its own universe with unique physical constants. In that vast landscape, some universes would collapse instantly, others would expand too fast for matter to coalesce, and a few, like ours, would find themselves poised at the delicate edge of balance. If that vision is true, then our flat universe may not be special by design, but by selection. We exist in the one universe where geometry allows for observers to ask why it exists. Yet, the idea of perfect flatness feels incomplete, because if the universe is truly infinite, then what does it expand into? When we imagine expansion, we picture something growing within something larger, a balloon filling with air, a ripple moving through water. But the universe has no outside. Its expansion is not movement through space, but the creation of space itself. There is no edge, no border, no frontier. Every galaxy is moving away from every other galaxy, not because they're drifting through a void, but because the void itself is stretching. This concept is almost impossible to visualize. The expansion of the universe happens everywhere, simultaneously, at every scale beyond gravity's reach. Between galaxies, space expands. Within galaxies, gravity resists. The result is a dynamic equilibrium, a universe that grows without breaking, that stretches without tearing, that remains infinite yet finite in experience. Still, the question remains, why this geometry? Why does the universe exist on the razor's edge between collapse and runaway expansion? Some theorists believe that geometry itself may be the fundamental ingredient of reality, that energy, matter, and even time are emergent properties of space's shape. In this view, dark energy could be not a separate force, but a feature of the universe's curvature, a pressure built into geometry itself. This idea transforms how we think about the cosmos. Instead of existing in space, everything becomes an expression of space. Galaxies are eddies in its flow. Matter is the condensation of curvature. Even consciousness, the awareness that tries to comprehend this vastness, might be geometry reflecting upon itself. So when we ask what shape the universe has, perhaps we are really asking what shape existence takes when it tries to understand itself. The observable cosmos may appear flat, but the deeper truth could be that curvature and consciousness are inseparable. If geometry is destiny, then dark energy is not merely stretching space, it is evolving it. The universe may not just be expanding, it may be changing form. And with every second that passes, the scale of that transformation grows. To grasp what this evolution means, we must look further, not into the visible geometry of galaxies, but into the invisible horizon that defines what we can and cannot see. Because in an accelerating universe, even the limits of perception are expanding, and the cosmos we observe is only a shrinking fraction of the whole. The vanishing horizon. Every observer in the universe lives inside a boundary, a horizon that defines how far light can travel before space itself outruns it. This is not a metaphor. It is the most literal wall in existence. Beyond it, light from distant galaxies will never reach us, no matter how long we wait. In an accelerating universe, that horizon is closing in. The cosmos is expanding faster than the speed of light can cross it. Slowly, silently, our visible universe is disappearing. When the universe was young, light moved faster than expansion. Every photon that left a galaxy could eventually reach another, given enough time. Space was connected. Information could travel. Gravity could weave structures across the cosmos. But since dark energy began to dominate, this has changed. The expansion of space has accelerated to the point where distant galaxies are being carried away faster than light itself. They are not moving faster than light. The space between us and them is stretching faster than light can traverse it. This creates a cosmic event horizon, a frontier of sight, a boundary of knowledge. Galaxies beyond this horizon still exist, but their light will never reach us. To us, they fade not because they vanish, but because the universe outpaces their message. Each second, another galaxy slips across that invisible threshold, becoming unreachable, unobservable, and, for all practical purposes, gone. In 100 billion years, the universe we see today, filled with hundreds of billions of galaxies, will have dwindled to a lonely handful. Only the galaxies gravitationally bound to ours, like Andromeda and the Local Group, will remain visible. Everything else will disappear beyond the horizon, leaving behind an expanding void. To future observers, it will seem as if the universe has always been small, static, and empty. The evidence of its true history, the cosmic microwave background, the distant clusters, the red-shifted echoes of expansion, will be lost forever. This is one of the most haunting consequences of dark energy. It means that cosmic knowledge itself has an expiration date. There will come a time when even the most advanced civilizations will be unable to detect that the universe is expanding. The sky will be dark, the background radiation gone, the stars thinned to a few faint embers. To them, cosmology, the study of the universe's origins, will be impossible. The evidence of creation will have faded into silence. And yet, the horizon is not just a physical limit. It is also a philosophical one. It defines what we can know about reality and perhaps what the universe allows us to know. We live at a unique moment in cosmic history when the universe is old enough to reveal its vastness, but young enough that the horizon has not yet erased it. We can still see the afterglow of the Big Bang. We can still trace the filaments of the cosmic web. We can still measure the expansion that defines our era. We are witnesses in a fleeting window of clarity between darkness and darkness. This coincidence has profound implications. Why do we exist at this exact moment, a time when the universe is still readable, when the sky still speaks of its own beginning? The odds are astronomically small. Most of cosmic time will not be like this. For the vast majority of its future, the universe will be silent, dark, and unknowable. Some scientists call this the cosmic coincidence problem. The fact that intelligent life has emerged precisely when it can perceive the grand architecture of the cosmos, right before that architecture vanishes. Is this timing pure chance? Or is awareness itself somehow tied to the structure of the universe, arising when the cosmos is both vast enough to nurture life and young enough to reveal its own nature? If so, then consciousness is not an accident of biology, but a phase of cosmic evolution, the universe briefly observing itself before the horizon closes forever. From this perspective, the vanishing horizon is more than tragedy. It is revelation. It shows us that knowledge is temporary, but awareness is timeless. Even as galaxies fade from view, the act of seeing, of understanding, remains. We, fragile beings on a small planet orbiting a modest star, are the cosmos in its moment of reflection. But the horizon's silence carries another question, one we cannot yet answer. If light can no longer cross the expanding gulf between galaxies, does that mean the universe's parts are truly isolated? Or is there still some invisible connection, some hidden field or resonance, that binds everything together beyond the reach of light itself? To explore that mystery, we must look past the limits of observation, past photons and telescopes, into the strange realm where quantum mechanics and cosmology overlap. Because there, in the unseen fabric of reality, might lie a deeper truth, that even as the visible universe fades, something beneath it remains perfectly connected. The quantum thread. If dark energy is the great force pulling the universe apart, quantum mechanics may hold the clue to why everything still feels bound together. Beneath the vast emptiness between galaxies, beneath even the particles that make up matter, reality is not a collection of separate things. It is a field, a continuous ocean of possibility. What appears as isolation at one scale may, at a deeper level, be an illusion. The universe, expanding and accelerating though it may be, could still be united by a hidden quantum thread. To understand this, imagine that every particle in the cosmos is like a note in a symphony. Each one vibrates in the quantum field, and though they seem independent, they are all part of the same underlying melody. In quantum physics, this connection is more than poetic. It is real, measurable, and unavoidable. It is called entanglement, the phenomenon where two particles remain linked even when separated by vast distances. A change in one instantly influences the other, no matter how far apart they are. Entanglement defies our common sense about space and time. It suggests that separation is not as absolute as we perceive. What we call distance may be an artifact of perception, not a property of reality itself. And in an accelerating universe, where dark energy drives everything apart, this becomes a profound idea. Perhaps nothing ever truly drifts away. Perhaps the universe is expanding only in appearance, while beneath it all, an invisible quantum web still binds everything together. If that's true, then even as galaxies disappear beyond our cosmic horizon, their quantum fingerprints remain woven into the fabric of reality. The connections persist, invisible yet intact, like a silent music humming beneath the static of space. The universe might be losing light, but not unity. This brings us to one of the strangest and most elegant theories in modern physics, the idea that space itself emerges from entanglement. In this view, the geometry of the universe, its shape, curvature, and even its expansion, is not a background stage upon which matter acts, but a structure built from information. Space is what happens when quantum systems connect in certain patterns. Remove those connections, and space dissolves. Strengthen them, and space expands. If so, then dark energy could be not an external force, but a consequence of this underlying information field. As entanglement changes across cosmic scales, the geometry of space adjusts in response, causing the universe to expand. In other words, the cosmos might not be pulled apart by an energy, it might be growing out of information itself. This perspective transforms the nature of the cosmic horizon. Rather than a hard boundary, it becomes a gradient of information, a limit on what can be known but not necessarily what exists. The farther a galaxy recedes, the less entangled its quantum state becomes with ours, until it slips beyond measurable influence. The universe is not losing parts, it's losing correlations. The web remains, but the threads fade from our awareness. Such a universe would not be dying. It would be evolving, reorganizing itself into patterns we cannot yet detect. Expansion would be a process of differentiation, not decay. Reality exploring its own possibilities by stretching the network of entanglement across ever greater scales. Some physicists have even suggested that dark energy may be the pressure of quantum information itself, a kind of entropy linked to the growth of cosmic horizons. As the observable universe expands, so does the amount of information it can contain. The acceleration of space would then be a reflection of the universe's drive toward greater complexity, not its collapse into emptiness. If that sounds abstract, consider the human mind. Consciousness itself seems to arise from networks of connections, billions of neurons exchanging information through electrical signals. When those connections strengthen, awareness deepens. When they weaken, perception fades. Could the universe operate the same way? Could its expansion be a form of cosmic cognition, a gradual awakening of awareness written into the very structure of space-time? It is here, at the intersection of physics and philosophy, that dark energy begins to resemble not a flaw in the equations, but a feature of existence itself. The universe may expand because expansion is what it means to exist, to unfold, to differentiate, to explore itself through creation. What looks like separation may be the necessary process of discovery, the cosmos learning its own nature by extending its own horizon. In this view, the quantum thread that binds all things is not broken by acceleration, it is tested by it. The faster the universe expands, the stronger that underlying unity must become to preserve coherence. And perhaps that is what life, consciousness, and intelligence represent. Local expressions of the universe maintaining its own connection through awareness. The same quantum field that shapes atoms also shapes galaxies. The same invisible thread that links entangled particles might link every thought, every star, every possibility. The universe does not merely contain connection, it is connection. But if the universe expands through information, if its geometry evolves through entanglement, then another question emerges. Where does this information go? Does expansion mean the universe is remembering more of itself, or forgetting what it once was? To answer that, we must turn to the concept of cosmic memory, the idea that every moment, every structure, every burst of energy is somehow recorded within the fabric of space-time itself. Because what if the universe isn't just growing, it's archiving? The memory of the cosmos. Every act of creation leaves an imprint. From the smallest vibration of a particle to the birth of a star, the universe records its own history in the subtle language of energy and geometry. Yet unlike human memory, cosmic memory does not fade. It accumulates layer by layer across time. Every moment of the universe, every explosion, every collision, every spark of light is etched somewhere into the structure of reality. If the cosmos is indeed built from fields and information, then every fluctuation of those fields must leave a trace. The expansion of space itself could be thought of as a vast recording surface, a cosmic archive storing everything that has ever occurred. And if that is true, then dark energy, which drives expansion, might also be the mechanism that preserves this record. As the universe grows, it is not just creating new space, it is creating new memory. This idea, though poetic, has roots in physics. According to Einstein's general relativity, energy and mass curve spacetime. Every event that disturbs this curvature, every wave, every particle, every photon, leaves behind a slight distortion, a ripple that persists long after the source is gone. The universe, in this sense, never forgets. The gravitational waves that pass through us today are echoes of events that happened billions of years ago. The light from distant galaxies is a photograph of the past, crossing the void to reach us only now. Even the faint hum of the cosmic microwave background is a fossil, the memory of the first light that ever filled the cosmos. But what about the parts of the universe we can no longer see? What happens to the memories of galaxies that have drifted beyond the cosmic horizon? Do they vanish into nothingness, or do they remain inscribed somewhere beyond reach? Some physicists suggest that the fabric of space-time might encode information holographically, that every region of space contains a complete, lower-dimensional record of everything that has ever interacted with it. This is known as the holographic principle, and if it is true, then nothing is ever truly lost. Even when matter disappears into a black hole or beyond our horizon, its information remains imprinted on the boundary of the universe. In this framework, dark energy could be more than a force of expansion. It could be the process through which the cosmic hologram writes itself. As space grows, the universe gains surface area. More area means more capacity for information. Expansion, therefore, could be the act of creation and remembrance combined, a self-recording universe writing its own history across the infinite scroll of time. It's a haunting thought. Every star that ever lived, every world that ever spun, every mind that ever dreamed, all of it may still exist, preserved in some subtle configuration of energy and geometry. The past does not vanish. It merely becomes unreachable. But if the universe remembers everything, then what does that mean for us, the small beings who exist within it? Is consciousness a byproduct of that memory, or a reflection of it? Perhaps the reason we remember at all is because memory is woven into the fabric of reality. When a neuron fires, when a thought forms, it is following the same principle that drives galaxies and gravity. Information creating structure, structure creating awareness. Some philosophers of science propose that the universe itself could possess a form of proto-memory, not consciousness as we know it, but a persistent awareness of its own evolution. Every event changes the configuration of the cosmic field, and in doing so, contributes to an unfolding story. From this perspective, the universe is both storyteller and story. It evolves not only through physical laws, but through the accumulation of information. Dark energy would then be the agent that allows this story to expand, ensuring that each new chapter has space to be written. But there is a deeper paradox here. If the universe preserves everything, then the more it remembers, the more fragmented those memories become. Galaxies drift apart, signals stretch into oblivion, and events separate by unimaginable distances. The cosmic record grows vast, but increasingly incoherent, a library of infinite books scattered by the winds of expansion. Perhaps this is the ultimate fate of all knowledge, not destruction, but dispersion. And yet, even as that dispersion continues, something remarkable happens. Life emerges, a phenomenon that gathers fragments of information back together, organizing them into meaning. Consciousness, in this sense, is the universe remembering itself in concentrated form. Every act of perception is a miniature reversal of entropy, a local defiance of forgetfulness. Through awareness, the cosmos condenses its own scattered memory back into coherence. Dark energy might be the cause of separation, but life and thought are its counterbalance. Where the universe expands, consciousness reconnects. Where memory disperses, understanding gathers. This delicate opposition might be the hidden rhythm of existence, expansion and recollection, entropy and awareness, the universe breathing between knowing and forgetting. In the distant future, when the stars have faded and galaxies have passed beyond the horizon, perhaps this balance will persist in another form. The record of all things will remain, encoded in the silent geometry of space-time, the cosmic memory of what once was and what it meant to be. But memory is not the same as purpose. The universe may remember everything that has happened, but why does it happen? Why does existence persist in unfolding at all? To answer that, we must look not at what the universe stores, but at what it seeks, the reason it continues to expand, evolve, and transform. The purpose of expansion. Every force in the universe seems to serve a purpose. Gravity gathers, light reveals, and entropy disperses. Yet the greatest force of all, the one that governs 70% of the cosmos, appears to do something far stranger. Dark energy does not build, or warm, or illuminate. It stretches, it separates, it accelerates everything away from everything else. To most, that looks like decay. But what if it's not destruction at all? What if expansion itself is the universe's most fundamental act of creation? From the moment of the Big Bang, expansion has been the universe's language. Before there were stars or galaxies, there was only growth, a sudden and unstoppable unfolding of space. Expansion is how reality expresses itself. It doesn't occur within the universe, it is the universe. Space is not stretching into something else, it is stretching into being. So perhaps the question isn't, why is the universe expanding, but why must it? Consider what happens in the smallest moments of life. A seed expands into a tree, a mind expands with knowledge. A civilization expands its awareness of the world. Even in human consciousness, expansion is the measure of existence. Growth is meaning. It's as if every process, biological, intellectual, and cosmic, is a reflection of the same principle, the drive to unfold potential into reality. Physicists describe this principle mathematically, but poets might call it evolution. The universe is not a static design, it's a living equation. Every atom, every star, every being is part of its expansion, not just in space but in complexity and awareness. From simplicity to structure, from chaos to pattern, expansion has always carried creation forward. In this sense, dark energy may not be a cold, indifferent pressure. It may be the expression of this cosmic imperative, the will of reality to continue becoming. As the universe ages, matter cools, entropy rises, and stars fade. But even as energy spreads thinner, expansion ensures that the story doesn't end. It opens new chapters, new configurations, new possibilities. And yet, there is an unsettling symmetry here. Every act of expansion creates both possibility and loss. The more the universe stretches, the more its parts become isolated. The more it grows, the harder it becomes for one region to influence another. Expansion gives life its chance, but it also guarantees its eventual silence. In this way, dark energy embodies both creation and separation, the twin forces that define existence. Why then does the universe choose expansion over stillness? Some cosmologists argue that the answer lies in energy balance. A universe with zero total energy, where positive energy from matter is exactly offset by negative gravitational energy, could expand forever without violating any law of physics. In that view, expansion is not just natural, it's inevitable. The universe expands because it can. But others see something deeper, a pattern that echoes throughout all scales of existence, systems that expand, evolve. Those that remain static decay. From a single-celled organism to an entire galaxy, vitality lies in motion. Perhaps the universe expands for the same reason life persists, because it is the nature of being to become. And here, the boundary between science and philosophy begins to blur. If the universe's expansion is a creative act, then we must ask, creative toward what? What is it building, if not more galaxies, more matter, more light? Could it be building understanding itself, consciousness emerging as the universe's self-reflection? Many physicists resist that question, but the pattern remains difficult to ignore. The same forces that make stars burn also shape the neurons that let us contemplate them. The same laws that guide galaxies govern the thoughts that name them. We are not observers of expansion. We are its expression. The local awareness of a process that began 13.8 billion years ago and continues through us. If that's true, then dark energy isn't just a distant cosmic mystery. It's the underlying rhythm of existence, resonating through every scale of being. It's why atoms bond, why life evolves, why thought expands beyond instinct into meaning. Expansion is not random, it's relational, a motion towards self-realization written into the fabric of reality. Perhaps the universe expands not to escape itself, but to know itself, to turn potential into experience, energy into memory, matter into mind. Every particle, every wave, every act of awareness is a fragment of that unfolding. We are not living in an expanding universe. We are the expanding universe. But if expansion is creation, it also implies transformation. The universe we know, bright, structured, full of light and life, is temporary. One day, expansion will erase it. Galaxies will vanish beyond horizons, stars will fade, atoms will disassemble, and even black holes will evaporate. Yet perhaps that too is not an ending but a transition, the universe discarding one form to make room for another. To glimpse what that next form might be, we must look to the ultimate consequence of expansion, the end state toward which all this growth is heading. Because if the universe expands to express itself, then how does it express its final thought? The end of everything. Every expansion must face its horizon. Every story, no matter how vast, moves toward its final chapter. The universe is no exception. From the first burst of light to the last fading glow, everything that exists is part of one long breath, a cosmic inhalation and exhalation spanning eternity. But now, we may be living at the midpoint of that breath, the moment between creation and dissolution. For the force driving the cosmos forward, dark energy will not stop, and its persistence means that one day, everything we know will end, not in fire, but in silence. If dark energy continues at its current rate, galaxies will drift apart faster than light can travel between them. The night sky will grow emptier. First, the most distant clusters will vanish, then the neighboring superclusters, until only the local group remains. Our Milky Way and Andromeda, locked together in their slow gravitational embrace. Over billions of years, these galaxies will merge into a single glowing remnant. Milkomeda, the last great island of stars in an ocean of dark space. Beyond it, the universe will be still. Not because it has stopped expanding, but because everything else has drifted beyond reach. The cosmic horizon will close like a curtain, hiding the past and isolating the future. The expansion will continue, but the meaning of distance will vanish. Space itself will have grown too vast to measure. Then, the stars will begin to die. The great engines of light that once illuminated the cosmos will exhaust their fuel. Some will collapse into black holes, others will fade into cold embers. New stars will form less often until the universe enters what physicists call the degenerate era, an age of slow decay where only remnants remain, white dwarfs, neutron stars, and black holes silently orbiting in endless darkness. If dark energy remains constant, this state will persist for trillions upon trillions of years. Time will stretch until it loses meaning. Black holes will swallow what's left of matter, and even they will eventually evaporate through Hawking radiation, releasing their energy into the void. When the last one disappears, the universe will become a thin mist of stray photons, faint, cold, and eternal. This is the Big Freeze, the final whisper of a cosmos that once burned with life. But if dark energy is not constant, if it grows stronger, the end will come differently, and far more violently. In this scenario, known as the Big Rip, expansion accelerates beyond control. Galaxies will not simply drift apart, they will be torn apart. The gravitational bonds that hold them together will break. Then, the stars themselves will disintegrate. Planets, molecules, even atoms will be ripped from existence as the very fabric of space-time tears under the strain of infinite acceleration. The universe will end not in emptiness, but in fragmentation. A storm of dissolution spreading faster than light, erasing structure itself. Both endings are devastating. Both are inevitable unless the laws of physics change. And yet, even here, in the universe's darkest future, there is beauty. Because both scenarios reveal something profound. Expansion never truly destroys. It transforms. Even in the Big Freeze, energy doesn't vanish. It disperses. In the Big Rip, space doesn't end. It evolves into a new configuration, one we cannot yet imagine. Perhaps this is the true nature of dark energy, not a force of death, but of renewal. The same expansion that drives galaxies apart may one day seed the birth of new universes. In the vast nothingness beyond our cosmic horizon, new regions of space could be budding even now, invisible to us but following the same timeless law of creation. If that is true, then the end of everything is also the beginning of something else, a continuation of the cosmic cycle. Maybe this is why the universe expands, not to dissolve, but to reproduce itself. Each dying cosmos might give birth to another, its physical constant slightly altered, its geometry slightly changed, a process of eternal refinement. In this view, the universe becomes not a static creation, but a living lineage, a sequence of ever-evolving realities born from the ashes of their predecessors. And what of us? What does it mean to live in a universe destined for silence? It means that awareness itself, the brief flicker of consciousness that allows us to ask these questions, is the universe's most extraordinary act of defiance. Against the pull of entropy, life creates meaning. Against the silence of space, it creates understanding. We are, in every sense, the cosmos attempting to comprehend its own end before it arrives. Even if everything fades, that act of understanding remains significant. Because to witness the universe is to preserve it. Every thought, every discovery, every question becomes part of the cosmic record, written into the very structure of space-time. In the end, the universe's expansion may erase everything except this, the memory of having been observed. So when the last light fades and the final atoms drift into the dark, perhaps something will endure. Not matter, not energy, but awareness. The same awareness that began when the first star ignited. The same awareness that looks up tonight and wonders where it all leads. Finally, when the universe breathes its last, perhaps that awareness will exhale too, and in that moment, begin again. Closure, the breath of eternity. The universe is not a story of decay, but of transformation. It expands, not to die, but to continue becoming. Every particle that drifts apart, every star that burns out, every world that vanishes beyond the horizon is part of a cycle far larger than loss. Because in every act of separation, there is also the seed of creation. Dark energy may pull the cosmos apart, but curiosity, the awareness born within it, pulls us back together. It reminds us that to question existence is to participate in it. We are not mere observers of the expanding universe. We are the universe, expanding through observation. So the next time you look at the night sky and see the galaxies receding into darkness, remember, you are watching the cosmos in motion, still writing its own destiny. And perhaps, somewhere in that vast silence, it is watching you too. Stay curious, stay awake, because the universe is not ending, it is becoming.